Question 2f. The liquid nitrogen boiled. What happens to the temperature of nitrogen as it boils? Right, now this is a really common misconception here. So when things boil, what's happening to them? There's a graph that you might remember seeing. Looks like this. So time here, time or energy, and over here we've got temperature. So what happens is you can take something like liquid nitrogen and it will be solid at very low temperature, and then it does that, and then it boils, and then it is a liquid, and then it melts here, then it boils up here, and then it's a gas. So we get is these bits here. This, for any material, this slope here is when they are solid. This slope here is when they are liquid, and this slope here is when they are gas. Now what that means is the bits in between, so here and here, is when it's changing. So this in particular, that's called melting, when it changes from a solid into a liquid, and here we've got boiling, when it changes from a liquid into a gas. And what you'll notice is at those temperatures, the temperature doesn't change at all. Now, we often imagine it goes up. It doesn't. The temperature does not change. Okay, it's the reason why if you've got a really simple recipe and you're boiling water, say, you boil an egg in water, it doesn't tell you what temperature to boil the egg at, because water will always boil at, or pure water will always boil at 100 degrees Celsius. Okay, so there's no point telling you what temperature to boil it at, because it will only stay at one temperature when it's boiling. Okay, next. The scientists recorded measurements to calculate the specific latent heat of vaporization of nitrogen. What is meant by vaporization? So we've got a key word here, a key term in terms of vaporization, and it's all about a change of state. So you can see that from these different values here. So vaporization, we've got to tick one box. Now there are clues here in this term. So the clue is vapor. Okay, and vapor we know is a gas. So if you think about a vapor, even the vapes that people sort of use now as an alternative to cigarettes, they are gas. Whenever we see ation, that's a process. That means there's something happening. So what that is a process of making gas. We can look down here straight away and we know it's not going to be that one there. Also solid to a gas, well, that doesn't, we don't often get solid to a gas. What we do get generally is we get liquid to a gas. So vaporization happens during boiling. It also happens during evaporation as well. But it's the process of going from a liquid to a gas. Part H. The mass of nitrogen vaporized was that. 1,440 joules of energy was transferred to nitrogen as it vaporized. Calculate the specific latent heat of vaporization of nitrogen. And I've got to use the physics equation sheet again. And it's worth 3 marks. So it's a calculate question. I've got mass is that. I've got that much energy. And if I look on my equation sheet, I'm looking for anything that says vaporization. I've got a feeling here this may actually be a physics of separate science only. Okay, yeah, so if you're doing combined science, don't worry, this equation isn't in your specification. So that's good news, isn't it? So you don't need to worry about this one. I'm trying to see where on earth it is in there. Okay, so for here, we've got the equation. I'll give you the equation here. So we've got thermal energy, so change in energy equals mass times specific latent heat. Okay, so that's the equation that you would be given if you were doing separate combined science. Okay, so we've got our equation. And even though you don't need to know this equation for trilogy science, for combined science, you still may be given it and then expected to use it. So I've got the equation. I'm going to write down my values. So I know that mass is equal to 0.0072. I know that energy is equal to 1,440 joules. So I'm going to pop those in. I'm going to enter my values now. So 1440 is equal to 0.0072. And specific latent heat, okay, again, you don't need to worry about this, but we use the symbol L. You can call it any symbol you like, doesn't matter. I'm going to call it L because it's latent. I'm now going to rearrange it. So I need to divide both sides by 0.0072. Gives me a value of 200,000, and it's given us the units already there. So when I check the units, they've already given us the units. Okay, in terms of this, you'll be given the equation, as I say. If you're doing combined science, it won't be in the physics equation sheet. They'll give it to you here. You get 1 mark for that, 1 mark for the rearranging, and 1 mark for the answer. Okay, so you always get a mark for the substitution, which is why we always do the substitution first. Okay.